All right, 7.4, more multiplication properties of exponents. What does the following expression mean? So let's talk about the inside, 3 to the second. That's 3 times 3, right? And the 4 on the outside means we have to do that 4 times. So 3 times 3 is once, there's twice, there's 3 times, and there's 4 times. So let's gather up how many 3's we have. 1, 2, 3, 4, 5, 6, 7, 8. So it would be 3 to the 8th. So, excuse me. Sorry, I had to cough. All right, so that is, what that means is we're just taking 3 to the second and doing that 4 different times, which ends up being 3 to the 8th. So this one again, we have 2 to the third, which is 2 times 2 times 2, and we want to do that 2 different times. So that's 2 to the 1, 2, 3, 4, 5, 6. 2 to the 6 is our final result. And so there's a rule that you can use. You can draw it out always like I was just doing. That works great. But the rule is if it's, if we had on the last page, we had 2 to the third to the second. So 2 to the third to the second. And we said that was 2 to the sixth. That's ends up being 2 to the 3 times 2. Which is the 6. So this rule is a to the m raised to the n power is a to the m times n. So if we have 4 to the second raised to the 5th power, that means we have 4 to the second, 4 times 4, 4 times 4, 4 times 4, 1, 2, 3, 4. I need it one more time. 4 times 4, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 to the 10th. The rule says it's 4 to the 2 times 5, which is also 4 to the 10th. Sorry, my smartboard is making extra lines again, so. All right, so let's do it without writing out this time. So z to the 8th, all raised to the third power, is going to be z to the 8 times 3, which equals z to the 24th. And k to the 5th, all raised to the 9th power, is k to the 5th times 9, which equals k to the 45th power. Oh, here we have a triple up, but it's the same idea. We're going to start in the center, and we have y squared raised to the 3rd. So that would be y to the 2nd times 3. So let's just start that. And then we have it to the 4th. So the inside would simplify to be y to the 6th. And then we have it raised to the 4th, which we know is y to the 6th times 4. So that's going to be y to the 24th. What does the following expression mean? We've kind of already talked about it. It means we're taking 2x 2 different times. So if I do that, 2x 2 different times, I again rearrange my equation so I have the numbers times numbers. 2 times 2 is 4. X to the 1st times x to the 1st is x to the 2nd, or if I count them up, I have 2 of them, so x to the 2nd. So what does it mean? We're taking that quantity, in this case, 2 times because it's raised to the 2nd. So this one also, we're taking that whole quantity and raising it to the, and doing it twice. So we're taking x to the 2nd, y to the 3rd once, and then x to the 2nd, y to the 3rd another time. That's what it means. We're multiplying it times itself. And now I rearrange things so they're where I want them. X to the 2nd times x to the 2nd. and then times y to the third times y to the third would be x to the 2 plus 2, so x to the fourth, y to the 3 plus 3, y to the sixth. Here's a shortcut to do it. When we talk about distribution, we have to distribute this raised to the second power to both of our numbers. So it'd be x to the second raised to the second times y to the third raised to the second. And we talked about if it's a power raised to a power, it's multiplication. So x to the 2 times 2, which is x to the fourth. Y to the 3 times 2, which is y to the sixth. So we get the answer either way. Whichever way makes more sense to you is what you should do. Product rule. So I'm just going to say the product to a power rule says that we need to distribute this. So it ends up being a to the n, b to the n. So again, let's see if I can get my thing to work. A to the n, b to the n. So we're going to distribute this fourth power to both of our pieces, and we would get x to the fourth, y to the fourth. And if we distribute this to all three pieces, we get -2, I'm going to put it in parentheses, to the third. And then we have x to the third, y to the third. So -2 times -2 times -2 is 2 times 2 times 2, which is 8, and it's going to be negative because it's raised to an odd power, so -8. And then I just have x to the third, y to the third. All right, this one, I'm going to distribute it to all of our spots. We get 3 to the second, our y to the second, and our z to the fourth to the second. So these are powers raised to powers. So 3 to the second is it's just 3 to the second, which is 3 times 3 or 9. Y to the second raised to the second. Again, it's y squared times y squared, or y squared 2 different times. Z to the fourth raised to the second is z to the fourth times z to the fourth, which is 9, y to the fourth, z to the eighth. Let's see. We have the next one, which is 4a squared quantity raised to the fourth power. So again, we have to distribute that to all the parts. So we'd have 4 to the fourth and a to the second to the fourth, which 4 to the fourth is 256. A to the second to the fourth is a to the 2 times 4. Power raised to power is multiplication. So we have 256 a to the eighth. Simplify, leaving no negative exponents in our answer, which is almost always the ideal unless it specifically says leave a negative exponent in. All right, that y to the third has nothing done to it right there, so it's just going to say y to the third. But this y to the fifth to the negative second, I'm going to move it and lose it right away. So I have y to the fifth, and then raised to the second. And so that's going to be y to the third on top, so I'm going to leave alone. Y to the fifth raised to the second, remember that's y to the 5 times 2. So I have y to the third over y to the 10th. And here I've been trying to avoid this the whole time because the book doesn't have us doing this yet. But let's just see if we can figure this out because that can be simplified. And we haven't learned division properties yet, so I could have rewritten this differently. But let's just do this. Y times y times y in the numerator. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them in the denominator. And I know y over y divided by y is 1, so those cancel out. Those cancel out, and those cancel out. So on the top, I have a 1. So I have 1 over y to the 1, 2, 3, 4, 5, 6, 7th. 1 over y to the 7th. I could have done it differently, so we didn't have the division part, but that is one way of doing it. Let's try to do this without the division part. N to the 5th raised to the 2nd is n to the 5 times 2. And this we have to distribute to all of the parts. So I have 4 to the 3rd, m to the 3rd, and then I'm going to put this one in parentheses because it has an exponent on it already, n to the negative 2nd to the 3rd. So here we have n to the 5 times 2, that's n to the 10th, times 4 to the 3rd, which is 64. M to the 3rd I'm not going to do anything with right now, but this would be n to the negative 2 times 3. So n to the 10th times 64 times m to the 3rd times n to the negative 6th. Now we have some n's we can take care of. So I'm going to just write my 64 m to the 3rd there because I'm not doing anything with those parts. But then I know n to the 10th times n to the negative 6th is n to the 10 plus negative 6, which is n to the 4th. I still have the 64 m to the 3rd here. And again, I still have the 64 m to the 3rd. But now I have n to the 4th. All right, this one, again, distribute to all the parts. We're going to have 6 to the 3rd, a to the 3rd, b to the 3rd, times 5 to the 2nd, a to the negative 3rd to the 2nd. There, it's all distributed out. Sometimes kids are tempted to do 6 times 5 here. We can't because that's not really 6 or 5. It's 6 to the 3rd, which is 216. A to the 3rd, I'm going to leave temporarily, b to the 3rd. 5 to the 2nd, 25. And then let's talk about this. It's a to the negative 3rd, negative 3rd times 2, which is negative 6. So a to the negative 6. Let's see, I have 216 and I have 25, so I can multiply those two together and I get 5,400. So that took care of that and that. I have a to the 3rd, a to the negative 6, so it would be a to the 3 plus negative 6, and b to the 3rd. So I have 5,400, can't do anything with that. A to the 3 plus negative 6, the negative 6 is bigger than the 3, so I'm going to have a negative answer. I'm going to have a to the negative 3 over b to the 3rd. And since I can't have a negative exponent, I have one more step. Some of these take a lot of steps, but if you just do them one step at a time, they're not bad. These things all don't change. The 5,400 or 5,400 and the b to the 3rd. But the a to the negative 3rd, I move it and I lose the exponent. Excuse me, I lose the negative. And that's your answer. Find the area of a square whose sides are 5x squared each. Let's look at it. If it's a square, it's 5x squared times 5x squared, and 5x squared. Area is length times width or base times height. So I just need to multiply them together. So area equals 5x squared times 5x squared. So 5 times 5 is 25. X squared times x squared, which is x times x times x, if we do it the simplified way, or the simple way, which is 25x to the 4th. And its area, so it'd be unit squared. All right, let's look at this. Ooh, we have a sphere who's got a radius of 10 squared millimeters. And the volume formula for a sphere is volume equals 4/3 pi r cubed. Leave your answer in terms of pi. We haven't done anything like this before, but that means we do all the number stuff and just leave the pi alone. So volume equals 4/3 pi. Our radius is 10 squared, and it's radius cubed. So volume equals 4/3 pi 10 to the 2 times 3, or volume equals 4/3 pi 10 to the 6th. And if I do, sorry, I just dropped my mic. 4/3 10 to the 6th. Actually, if you just leave it like that, I am fine with it. That would be in millimeters cubed. And complete these. So we talked about the fact that if we're multiplying things with the same base, it would be 5 to the 2 plus something. I don't know what that something is, so I'm going to call it x, equals 5 to the 11th. I know this and this have to be the same. So I'm just going to set up 2 plus what equals 11. So if I do this mathematically, and some of you are just going to do it in your head, x equals 9. So if I wanted to fill that in, it would be with a 9. So this one, again, I know that c to the negative, it would be c to the negative 5 plus something, I don't know what that is, equals c to the 6th. So I know that exponents have to match, so negative 5 plus something has to equal 6. So to solve this, I add 5. And you get x equals 11. So c to the negative 5th times c to the 11th equals c to the 6th. And there, that is all. We'll do the Math Excel homework in class.